I've recorded 2 of the 3 math things. The third math thing is very short. It's not going to be long at all. The second one is kind of the main one. The first one, it's useful to like review, but it should all be kind of mostly review, I think. I don't think any of it will be like surprising to you. The second one, where I talk about modular arithmetic primes, GCD, extended Euclidean algorithm, Diophantine equations, all that sort of stuff, I think will be the probably the most new for some of you. But anyway, one of the topics that's in there are prime numbers. Prime numbers come up a lot. It's something that it's really helpful to be able to code well on your own. And so I wanted to go through and show you how to code up a prime sieve just as a way of implementing these. Now, probably some of you have done this before. It's the sort of problem that they sometimes will give you even in an early coding class, because it's not that complicated in terms of the code that you need. And it gives you some nested loops and stuff that are always a nice example. So excuse me for 1 second. Arrange my screen. Okay, so I will all right, so what I'm going to have in main is I'm going to have a routine. I'll call this routine gen primes, and I'm just going to call gen primes in the main routine. And once I've done that, that's going to say generate new prime numbers for me. It's going to generate a list of prime numbers, and then maybe I can go through and I can check and say, is a number prime or not? Okay, so let's give an example of how some of this works. So I'm going to eventually keep track of a vector of all of the primes. So I will say vector int primes. Okay, and I'm just going to make this global variable to make my life easier. And I will also keep track of a sort of Boolean array. So I will keep track of a vector of Booleans, and I'll call that is prime. Okay. So is prime is going to be a vector where every element is either true or false, telling me is that number prime or is it not prime. Okay, so I'll have my routine here, gen primes. And it'll do whatever. And then I guess in my main code, what I'm going to do is I'm just going to read in numbers and output, yes, it's prime, or no, it's not prime. Okay, so first of all, I'll say the first 20 primes, just as an example. So you can see what this is. And I'm going to output the results of whatever is in primes. Okay, so all that's doing is it's going to print the first 20 things in the primes array after I've generated them. And then for the rest of it, I'll just say, while true, integer x, I'll read in x, and I'll say if is prime x, okay. All right, so there we go. We've got input, output. We're going to generate our primes. We're going to just read stuff in, and we're going to output whether it's a prime or not. Okay? Makes sense? Everyone's good so far, I assume? Okay, so for gen primes, the way we're going to do this is the Sieve, however you pronounce it, of Erastothenes, another name I can't pronounce. Okay, so the basic idea is we are going to initialize our entire array of primes, and let's just set some max prime value. So I'll set a const int max prime of, I don't know, maybe 1,000,000. Okay, so I'm going to set that. I'm going to say I want to generate primes up to 1,000,000, not 1,000,000 different primes, but up to primes of whose value is at most 1,000,000. Okay, so what I'm going to do is I will initialize is prime, and I'll resize it to max prime plus 1. And I will initially call everything true. Okay, so I'm going to initialize my entire array to true. I'm going to say every number is prime to begin with. Basically, I'm going to go through and I'm going to start marking things as untrue after this. So I'll also set is prime of 0 to be false. 0 is not prime. Is prime 1 to be false, because 1 is defined to be not prime. And now from here on out, I'm just going to run through my code. So I'll say for int I equals 2, I is less than or equal to max prime I plus plus. So I'm going to basically run through all of the numbers, and I'm going to see if that number is currently prime. And if it is prime, I'll add it to my list of primes. I'm going to say, yay, I found a prime number. And then I'm going to mark every multiple of that as not prime from there on out. So the first thing I do is I say, if is prime of I. So if it's a prime number, then I'm going to do more stuff. Now, if it's not prime, I don't do anything with it. I'm just going to go on to the next number. I don't care about it anymore. But if it is prime, then I will go ahead and I will push it to the back of the primes array. Okay, so I add I to my list of primes. And now I'm going to take every multiple of I from there on all the way to max prime and mark them as false. So I will say for int j equals, so I'm going to start out with I plus, I plus I. Okay, so it's going to start out at 2I. And as long as j is less than or equal to max prime, and every time I'm going to increase j by I. So I'm going to go through all of the multiples of I here. So if you need just a second, look at that code. J, it's going to start out at 2I, then it's going to go to 3I, 4I, 5I, 6I, 7I, and so on. Every time it's just adding one more I on. Okay, and each time it's going to say is prime of j is false. It's going to say that is not a prime number. Now, some of those we've already gotten marked as false. That's okay. We'll just keep marking them as false. Doesn't hurt to keep marking. Okay, and believe it or not, that's it. Now we're done. We've actually generated our list of primes. This will keep track of everything for us. We're going to go through all the values and run through there. So let's see if this works. The answer would be no, because I must have forgotten to close a bracket here. Okay. All right, so I'm going to run this through. So this was my list of the first 20 primes. So we should look at this. It should look right. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, all the way through. We could have printed up all the primes that we had as we generated them if we'd wanted. And now I can just type in numbers. So I can say 1 is not prime. Okay, 2 is prime. 4, 44, no. 107. I don't know if it is or not. It is prime. Okay, so I can just type numbers. I can look them up then. I have a quick table that lets me look up and say, is a number prime or not? So some of the problems that you run into, that's what you need to know. You just need to know, is my number prime? You have that in this giant array. a giant vector of Booleans that you can just immediately look up and see if it's prime. Sometimes you actually need the list of primes, like I printed out there, because you're going to like factor something by primes. Okay, if you're factoring by primes, if you're trying to do a prime factorization of a number, how far do you need to go in order, like as you're factoring? The ideas, like how many primes do you need to check? If n is your number that you're wanting to factorize into primes, how far should you go in the list of primes? Okay, so n divided by 2, sort of. Believe it or not, you can do better. You can actually do n square root of n, because you're going to encounter 2 before you get to n, and then it's going to reduce. So you're right, your factor could be n over 2, but if you just keep going to the square root of n, you're going to pull out like all the low factors first, and the things you'll be left with are the high ones. And basically, the high one can't be bigger than the square root of whatever's there. So if you kind of work your way from the low factors up to the high, you can get there. So I'll show you an example of this. This is not, since we ran through there, since we ran through that quickly, I think I can do this, but I have not coded this up. So just get ready for before. So I might have issues here. So rather than just checking is prime, I'm going to read in x, and I'm going to have some routine that says factorize x. Okay, so I'll have a routine here that I'll create called factorize. And basically, I'm going to run through my list of primes from beginning to end, and I'm going to try to keep dividing through by that prime. I'll see if it divides it, and if so, that reduces the value. And then finally, I output whatever is at the very end. Okay, so I can say, let me add one more thing up here. Okay, so I'm going to say int I. This is going to keep track of which prime I'm on. And I am going to continue as long as primes sub I is less than or equal to square root of x. Okay, and I'm going to check to see if that one divides through or not. So I will say if x, to see if it divides exactly, I do it modulo that value. So if the modulo value is equal to 0, let me parenthesize this just so there's nothing weird. Okay, that means that it divided exactly. That means that that prime number went into x perfectly. Okay, if that prime did not, then all I'm going to do is I'm going to increase I and go on to the next prime. Okay. But if it did, what I'm going to do is I'm going to print out that prime. So I will see out prime sub I and the space. And then I will, I'll just end there. So I'll print out that prime, and then I will reduce x by that value. Okay, so I'll divide through by that prime number. Does that make sense? And then finally, when I get to the very, very end here, I can say if x is greater than 1, then I will see out x. So I'll output whatever the remaining factor is. Otherwise, I'll just end my list. I'm not sure that'll ever happen, but that's what we have there. Okay, so there's my routine to factorize. So the idea here is I'm going to go through as long as my prime is less than the square root of x, that means that I should be able to still have a divisor. If it's greater than the square root of x, and I've already checked all of the smaller primes, so there can't be a prime smaller than me, and now I'm greater than the square root, that means none of the remaining primes, no matter what they are, even if I squared them, they'd be too big. And so all I'm left with is whatever x is, and x itself should be prime at that point. Okay, so I'm going to continue to do that, and if it divides, then I output that one, and I reduce x by that amount, and if it doesn't, I go up to the next prime. Question? Yes, so the bound would keep lowering. So as x keeps getting divided through, it'll keep getting smaller. You don't have to keep like going up. Yeah. So this is the prime factorization of a number x. So the gen primes up here, that will generate all of the primes up to whatever your max prime value is. So like, up here, just in case I wanted to do, instead of 20, let's just say I do 200. I've already generated those. But now that I've generated them, I've called gen primes already. Now I'm going to read in x, and I'm going to print out the factorization of x. So in fact, I can do. And we'll see if this works. Because like I said, I haven't even tried this. This is off the top of my head. But okay, so I do that. This is the first 200 primes, so we're getting up to bigger values there, just so you can see. And then if I have a number like, let's try 8. 8 factorized is 8. That does not sound right to me. So I think I have a bug. Let's see about 2. Okay, 2 factorized is 2. At least there's something. Okay, so so it would help to set I to be 0. Let me make sure that this is correct. Prime sub 0 should be 2, and 2 should be less than the square root of 8. So hopefully this will work. Yeah, okay. So 8 is 2, 2, 2. Oh, question? Oh, no. Yeah, so 8 is 2 times 2 times 2. So that's the prime factorization of 8. If I were to do something like 1024, should get lots of 2s. If I have a number like 17, I just get that. A number like 34, be 2 and 17. 18 would be 2, 3, and 3. Okay, I mean, we can pick. Okay. So anyway, you can do something like this. I guess 643 is prime. I did not know that. Look up here in the list. Yeah, 643 was in fact a prime number. Huh. Okay. Right. Yeah. So 643 is 643. Okay. So that just shows you some of the stuff you can do with primes. It's not too difficult to do some of these factorizations and things. Often, if you run into these in a problem, the prime factorization is a step along the way, or like generating the primes is a step along the way. It's very rare that that's the answer that you would want. It's just you need to get those in order to do something else. You should expect probably, I've been trying to hold back on lab problems that had prime factorizations and stuff like that, but there might be a lab question or two in the future that have prime factorizations as part of them, and hopefully that's something that's possible. They're not like, I don't intend for them to be super tough, the ones I'm thinking of. There could be really tough ones, but the ones I'm thinking of are not super tough, but you'll hopefully see the idea. Okay, so that's actually what I had for today. I won't go through the extended Euclid algorithm, although it's not that bad either if we wanted to code it up, but there's not really time. And I think that was probably more useful than extended Euclid. Does anyone have any questions? Yeah, look at the code. So do you want to look at the factorize or the gen primes? Does that answer what you wanted to look at?